Hi, good afternoon, everybody. Thank you for joining us. I am Swapnil, and this is Florent, and we're going to talk about Project Riff. So, won't go to the next one. Right, so Project Riff is not yet production ready, and features may change. So with that disclaimer, let's talk about what it is. So let us assume for a bit that you've just heard of this new thing called Kubernetes, and you want to get your app deployed on Kubernetes and play around with it. So this is what your typical workflow would look like. So you write your application as usual, then you create a Docker image. By authoring a file and then doing plugins, you do Docker build, push, you create a Kubernetes deployment and a Kubernetes service, and that may or may not involve a whole lot of YAML hacking. And then to iterate on your built application and to get that thing again running into Kubernetes, you commit your changes, you do the build push thing again, and somewhere down the line you are going to set up your CI/CD in production, but you're not going to do it for just playing around, right? So let's see how using Project Riff is going to help you out. So for getting your application up and running in Kubernetes, it's basically just two CLI commands. So it's only riff create function, and you give it the URL of your Git registry, Git repo, and that's it. And then you say, riff create a deployment. To iterate on your function going forward, all you need to do is commit new changes, and it will automatically get picked up and deployed on Kubernetes. So to explain how that whole thing works, here's Florent.
So let's get a bit into the details of how what Swapnil talked about. So Riff means Riff is your function, because recursive acronyms are fun. And so historically, Riff started as a function as a service. So the idea of a function as a service is you write and provide a function, the platform builds it for you, and then deploys that workload so you can interact with it. So Riff is open source. It's the open source core of a pivotal function service. It runs on Kubernetes and uses Kubernetes native concepts to get you running with as few simple steps as possible. So in function as a service, the important concept, as you may already know, is a function. So here are 3 valid Riff functions. So in that case, we show the different languages we support. So on the right, I was about to say on the left, but that doesn't matter. So you can see a Java function using the simple Java util.function API. When you given an input, computes an output. You have the equivalent of what we call the command. So a command is something that reacts to a standard input. So in that case, it's written in bash. You get some data from the standard input, and then you compute the uppercase version and output it in the standard output. And likewise, we also support Node.js and JavaScript. In that case, it's just a simple square function. So those are valid functions, and of course, in your case, it would be some business logic that you will work on and encode in a similar way. So that's what you write. But then you need the Riff CLI, so you can grab it from the binaries, from Homebrew, from Chocolate if you're on Windows. And in that case, what do you say? So you use a Riff CLI, you want to create a function, you give it a name, so that later the Kubernetes custom resource is created and you can refer it by its name. So the first thing you need to tell is where the sources are, so they can be remotely available through GitHub, like in that example. It could be locally with a local path flag. And you may need, depending on the language you target, you may need to refine the location of the sources to tell exactly where the function host is. So in that case, it's a shell script, so we tell the file that defines the computation. And then, so once you told where the sources are, we can build it, but we need to publish an image. So for that, you need to provide coordinates. So the command we don't show here is how to configure credentials. It's quite an easy command as well. You can see it in the docs. and then it will attempt to grab the sources, build it, and publish it to the coordinates you wrote here. And then if you want to follow the logs along to see what's going on, you just need the tail flag. So basically, given function sources, produce an image. But if we dive into a bit more in the details of what's going on, so actually Riff recently switched to Kpac, which is a cloud-native build-pack implementation for Kubernetes. And so there has been a session earlier this afternoon about that, but if you missed it, I will try to give it the gist of what it does. So as usual, you provide the function, and the build packs will try to layer the image in such a way that whenever there is a vulnerability at some level, you don't need to change the other layers, for instance, so that updates are minimal, so fast to apply. And also, given the structure, it's easier to have a consistent set of deployments across your organization, like using the same base image, for instance, etc., etc. And I also like this visual representation because it reminds me of a quote from Dave Sire, who is here in this room, that says that defined serverless 2 years ago in SpringOne by saying that there is even more you don't care about, right? We are familiar with infrastructure as a service, platform as a service, and here it's kind of a visual representation of all the things you don't care about that we provide for you, right? You provide the function source, and then all the other layers are basically provided by Riff, by coordinating what Kpac does for us. But that's not it, right? At this point, you provided the functions, you pointed to the sources, you got a produced image, but then you don't have a workload deployed on your cluster at this point. You just have a description of that image. So you have several options. So that's kind of recent. So now we support several runtimes. So historically, we started with a Knative integration, but now we offer more. We offer a minimal runtime. I mean, minimal at this point. Maybe it will involve and build and take more features as the weeks come. And we have also a new streaming runtime that we're excited about. We've been working on for several months now. So if you want to get started with Kubernetes, Riff Core is a good way to go. So it does very little, but just what you need, the minimum you need to get your image deployed onto your cluster. So it creates a service for you and a deployment with sensible defaults. And how do you do that? So again, the Riff CLI comes to the rescue. So this time you need to target explicitly the runtime you're interested in. So it's not Riff anymore, it's Riff Core. Then you invoke the deployer create command, giving it a name, because again, you will have a custom resource that you can refer later by that name. And you just need to give a reference to the function you built earlier, right? That's why you gave a name to the function. And then it will create the deployment for you with pods and expose a cluster internal service. So in that case, for demo only, we are forwarding a local port, so we can curl the resulting workload as if it was deployed locally. So that's why we map a local port to the remote one. And then we curl as usual. So in that case, it was the uppercase function that we saw earlier. So you just need to set the content type, send data in, and get data at the end. So it's that as simple as that. And so far, no YAML and no eyes hurt. So Knative as some kind of analogy, you can see it more or less as Spring Boot for Kubernetes. So it comes with opinions about deployment strategies, with also many configurable features, such as metrics, etc. And one important feature is the auto-scaling. So that's kind of what you hear often when someone talks about function as a service or serverless platform. So it can scale to 0 when there is no traffic coming to your function, and then scale on demand when the traffic rises, and again back to 0 if needed. And what it will do, so I will not dive into the details of how Knative works, but it will create a configuration for you, a route, so that you can interact with the workload you deployed. And it can also back away if you already configured, because you have many configuration options, so we can't possibly interface all of them in the Riff CLI, that would be too much. So you can also configure yourself the route and the configuration as you wish, and then we have a tiny adaptation layer that you can use with the CLI. But here we just show the basic one, so the deployer. There is also a Riff Knative adapter create in case where you have already configured everything. So Riff Knative to target the runtime, deployer create again like in core, and very similarly you also you give a reference to your function, then we will create everything that Knative needs so your workload can be queried. And depending on the Kubernetes distribution you use, whether it supports load balancer services or not, if you configure DNS or not, the way you will contact the ingress may vary, so it's well documented on our website. But then it's very similar to the core example, right? There is just one extra header because internally Knative needs to route the requests to the proper deployed workload. That's why you have this host here, where we suppose that the function has been deployed in the default namespace, and we have like a default configuration for example.com. But the rest is very similar to what we've seen before, and by doing that, you also get auto-scaling for free. And finally, there is a Riff streaming work time that we've worked on for a while now. So it's reactive first. We really want to support stateful streaming as a first-class citizen. So also it's been a few months. We're barely starting, so to say. There are still a lot of things to evolve, but so the main concept, so far what you've seen with functions, you've seen functions that accepts one input and computes one output. Here is a little bit different. You can write, so those functions are still supported and will be transparently promoted to streaming functions for you. So you can still use your classical request reply function with the streaming runtime. But if you want to, and we will show in a later slide how to do that, you can also write multi-input output functions that will accept input streams. Then you can wire up your computation pipeline and produce output in the output streams. And what happens under the hood is that the Riff system will map those input stream and output streams to broker topics. So that's the thing you need to provide beforehand. You need to have Kafka available somewhere, for instance. So Kafka is the only broker we support for now. There will be more later. And once you have a Kafka available, then you will have a provisioner that will create topics on demand and map them to stream. And those streams then will be exposed to the function you write. So also the scaling, the auto-scaling, of course, is a bit different because in request reply, it's as simple as counting incoming requests and just adapting the number of instances you need. In that case, when you talk about streaming, you can think about an infinite stream. So it's not exactly one request, it's a bit more complex than that. So we are using, we contributed to Kpac. So Kpac is an auto-scaler implementation. It's an open source project that we're using to try to scale based on the input lags. So the more event we have not consumed, the more instance we'll try to stand up just to make sure that we reduce the processing delay. And finally, a very recent addition. So it's still kind of a POC at this point. So you can set up a streaming pipeline, but you need also some data in to start, so the data can flow. And for that, we've introduced very recently a gateway where you just post your data to the input topics at the edge of your pipeline, and then the streaming pipeline, the data will flow naturally. Because of course, here I show a single function with several inputs and outputs, but you could have these output topics. They could be also inputs for another function, etc. And that's how you can build an entire pipeline. But as I said, you need to feed some data in. That's what the gateway is. Also, the shape of that gateway may change in coming weeks. So here the example is a bit different, of course, because concepts are a bit different compared to the core and Knative runtime. So as I said, you need streams first. So here we just create one input stream. That's the first command. So we refer to the provisioner. The provisioner, so in that case, it's only for Kafka at this point. That's the only broker we support. But that's what's going to actually create topics onto the Kafka you pointed to. And then we also add the content type just to specify what kind of data, what kind of format we accept for the data addressed in these topics. So similarly, we do the same for the output topics. So far, there are just two streams. And the fact that there are inputs and outputs are when you create the processor. So it's more or less the counterpart of the deployers we've seen before. So what do you say? You still have the function ref. So as I said before, it can still be a simple request reply function, and we will automatically transform it into a streaming function. You give it the input topics, can be several ones. The output topics, likewise, there can be several. And then the pipeline is set up, and you can start posting data. And as I said, we support different kinds of function in that case. So we had simple examples of command, Java, and Node.js previously. Here we also support streaming functions. So in 2 languages at this point, there will be more coming soon. So it's the same implementation in Node.js and Java. That is a repeater function. So it takes basically numbers and words and repeats the words the specified number of times. So I can say I can send 2 on one topic, hello on another topic, and I will get hello produced twice on the output stream. So that's the exact same implementation. So for Node.js, every library, in that case Highland, everything compatible with this node stream, the basic node stream will work. In the Java case, we leverage the Reactor API, so that's what you got with Flux and tuples. And that's about it. So we support Java and Node.js at this point for streaming. So I omitted tiny technical details for the Node.js functions, but those are going to go away later.
All right. So in summary, Riff has 3 runtimes that you can deploy your functions to. And this is just a little flowchart to help you decide which runtime would be appropriate for your functions. So if you have a fire and forget function, deployed on the streaming runtime. If you have a request and response, you have options. So then again, with the request response function, if you are worried about the latency and if having a cold start to your function is going to be a problem for you, then go ahead and use the core runtime. If, however, auto-scaling and scaling down to 0 is more important, then you can use the Knative runtime. So that's actually not all. There's even more. So what we saw was you gave us a function, and then what we ended up doing was contribute the invoker layer and as well as the underlying operating system layers to build the image. But what we really were running is an image. So in addition to giving us a function, you can also give us an application wherein you are giving us the invoker layer as well. And why stop at that? Since we are building a container anyway, you can give us a container and we'll happily run it for you. And so what that really means is all of those 3 abstractions that we provide for your user code can be deployed on all of the runtimes that Riff provides as well. And the dotted line is not yet, but we'll get there, and you'll be able to run applications and containers on streaming as well. But the solid lines is what is supported at the moment. So again, in order to, we've seen how to go ahead and create functions previously, right? So I think here. So in addition to functions, we can also create applications and containers. And once you have those, you can again deploy them on any of the runtimes of your choosing by using the application ref and the container ref in the CLI. So to summarize, basically what Riff is trying to do, we are trying to provide a serverless experience for your functions, applications, and containers on any Kubernetes, which can even run on-prem. And the benefit that I guess is mostly associated with serverless is really the price. But I would say that price is not the only advantage. Reducing boilerplate code, standardizing your build containers, they goes a long way in the whole serverless experience, right? So that's what we are trying to provide. And now let's talk briefly about some guidelines that you can use for building applications which are composed of functions. So for any application, I guess the first point is sort of straightforward. You identify what inputs you have and what are going to be the outputs for your application. And so for the inputs, then you end up doing a bunch of things, right? So you have to enhance the input. So for example, if latitudes and longitudes are coming in, you, for example, identify the city where that coordinate is and stuff like that, right? So you do enrichment. You also join multiple inputs, and that results in your output. So those are the first two steps. And once you've identified them, then based on if the function are going to be request reply or fire and forget, then again you figure out the correct runtime to deploy them on. And if you're going down the whole streaming runtime, then it is advisable to materialize your output. So your stream is immutable, right? It is going to store all the events, but recomputing that whole thing every time a user requests for data is a bit much, I guess. So you could materialize it and store it. You can always recreate it from the stream. So here is again Florent going to talk to us about a sample application.
So if you attended the keynote this morning, so Mark Fisher, our project lead, talked about a very big shopping cart application. So we're just focusing on one tiny aspect in that case. So likewise, like he presented this morning, we have cart events. So someone identified by a user ID adds or removes items from his cart. Then there are also add events. So here it's a simplistic model, so bear with us, but it's just, to show at least some live action, screencast action. So add event is what? It's about an item, there is some promotional contents, and it might be of interest for people interested in another item. So that's how we modeled it. And the outputs here is a contents recommendation for a specific user. So based on the context of what he did with his cart, his or her. And so to try to map it to the concept we've seen earlier, so we will use Gateway to ingest data, so to send events, and get the data flowing. Then the cart events, we will post them so that they land on the cart event stream. Likewise for the ad and the ad events that will land to a dedicated stream as well. Then we'll have a streaming function that will read from both the streams, join them, and apply a very sophisticated machine learning algorithm, as you're going to see. Basically a bunch of if-else statements. And then it will compute a recommendation for an ad for the user. So before showing the screencast, let me show you a little bit of what it looks like. So it will serve as a recap as well. Okay, let's move to the right window. Here we are. And let's go to presentation mode. If I find it, or I can just, okay. So you just need to depend, as you can see, so you can get the basic Spring Boot starter, get Reactor for the flux and the tuples. Here we have a function, so as I said, the inputs are cart event and add event, so flux that maps to those to the data flowing in the topics. Then we do a join, and then we have this very interesting algorithm that will basically try to recommend an app for the user. But it's not, the contents of the algorithm itself is not super interesting, but as you can see, it's just a simple Java function in the Java util.function sense, with some leveraging the Reactor API as we've seen before. And now let's switch and try. Okay. So I don't see the slide where I should. Nope. Sorry about that. Even we have a demo fail with a screencast, so that's interesting. And here we go. So let's see what's going on. So as I told earlier, so it may be not super visible, but Kafka is already available here. So that's what you need to provision first. So the Riff system will not help with that. So you need a provider that will be configured with the Kafka address. And so this provider is made of a provisioner that will create topics on demand whenever you create streams with the Riff CLI. And the leakless here is a streaming gateway, so basically we get a unified interface, whatever the underlying broker is. So at this point we only support Kafka, but leakless supports actually more, like Pulsar and other brokers. So we don't talk directly, Riff doesn't talk directly to the broker, we go through this intermediate step. So that's what you see, all these things here. So hopefully we see the comment or not. So now we just, okay, hopefully the title will go away, but we create the streams we need, so the card events and add events, because those are going to be our inputs. Then we'll do the same for the output stream. We create the function, so in that case it's remotely available with this Git repo. And we have a specific module, so that's why there is a subpath, but basically it will point to a Gradle project. Then the part that takes the longest in this demo is actually getting a Kpac to build the function, so grab the sources, analyze what kind of runtime it is Java, Node, or something else. So it's Java, then is it Maven or Gradle? It's Gradle, then grabbing Gradle, triggering the Gradle build, getting the package, so it takes a little while. But once the Gradle build succeeds, it will package it and deploy that to an image, as we specified with the Riff CLI. So all of that is done transparently. And once the build is done, we can create a streaming processor because it's a streaming function. And then we will be able to curl to the gateway. So it takes a little while, but then here we go. So it's creating all the layers, pushing the image, publishing the image somewhere, and then we will go through the processor creation with the command right there, with the 2 inputs and the single output. And as you can see on the right, there is a pod provision here for the processor. And then once it's ready, so we are taking a little shortcut here for the demo. So we're basically exposing a local port for leakless, so we can spy what's going on in the topics we interact with. And we also open a local port for the gateway, so we can get data flowing in. So at the bottom here, it's spying what the output stream will receive, so the result of the streaming function, basically. And the 2 other are just making sure that when we post to the topics, we see them in the Kafka topics as well through leakless. So the 2 top windows are for the inputs and spying on the inputs, the 3rd one for spying on the output. So here we just curl locally to the gateway when we send some cart events. So in that case, the user adds drums, shoes, and then removes drums. Then the add events we sent is an add about drums that are related to guitar, saying drums are great. And because the user removed drums, it doesn't have drums in his card, so we comment the drum add. And that's about it for this short demo. And let's try to move again. So we can expand, if we had more time, we would expand the demo to be a bit more complete. So the add recommendation is just a step in what we could really show. Like we could, as Swapnil mentioned before, we could aggregate the results in a kind of table view, with the stream table duality that Mark mentioned earlier this morning. And then that would be easier to serve in a home page where you could see the contents of your cards and then add relevant to whatever you have or added or removed from your card. And of course, there is much more that we didn't have time to cover today, at least not into all the details. So I really recommend that you take a picture of this slide because that's all the references if you want to dive into a particular topic. One important thing I think would be the Slack one. So Slack is open. We have a dedicated Slack for the project, so we welcome really everybody. If you want, just to try it out and you have some issues, we can help you out with this. The documentation and blog is on projectriff.io, so that's there are many getting started guides to get you started. And of course, so there is an ongoing effort to specify formally the invoker part. So right now so there is a protocol that we have implemented for Java and Node. We are barely getting started with a Python invoker, and if there is any language you like and you would like to see support for that, a good start is to read the spec. So it's still a work in progress, but it's interesting to at least to get a good understanding of what the stream protocol is. And again, if you want to contribute, you're more than welcome to do so. And the CLI itself is it's also listed, the Helm chart. So if you want to install a runtime or several runtimes, you can go through Helm. And there are a lot more. So the samples as well, if you want to get some inspiration, depending on the language runtime you're interested in. And I think that's it. So if you have any questions, feel free to ask now.
Can you schedule a function? Not yet. So, so I guess we only have 3 runtimes by default now, but the intent is to support more and more runtimes. So we're already thinking about a task runtime, which could potentially do some sort of a scheduling, but that's not there yet. There's a POC that Thomas worked on. We are on 0.5 snapshot at the moment, so I would not recommend production.
Yeah. The docs are online, but yeah, don't use it in production. Keep it a happy place. Any other questions? Anyway, I think we don't have time for questions, but
Thank you.
Thank you.